Here we go. We're finally starting chapter 2. But before we get started, let's review a little bit of chapter 1. All right, first, we got to classify these two numbers or name all sets of numbers to which each real number belongs. So let's get started. Look at that first number. Notice I can write it as a fraction by putting it over 1. So therefore, it has to be rational. All right, now can it be a little more specific? Is it an integer? All right, to be an integer, it can be either negative or a positive whole number, and 0 meaning, look, is there any decimals after the decimal place? No, we've got a repeating 0 here. All right, we got nothing but zeros after that decimal place, so that is going to be rational because I can make it a fraction, integer because there's no decimal piece at all. Is it a positive integer? Or 0, yes, it's positive, so that means it's whole. There's no decimals, and it's positive. And then natural, it's not 0, so it's natural. All right, the next one. This guy is not one of our perfect squares, right? Square root of 15 gives us a non-repeating and non-terminating decimal. So therefore, that's going to be, 3 point something, 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 kind of like pi. Doesn't terminate, doesn't repeat. So therefore, we call that irrational. All square roots of non-perfect squares are irrational. Okay, now we got to find out if these are greater. Which one's greater? All right, what we do is we line them up vertically, and then we find what they're equal to. Square root of 34 is approximately 5.8309, blah, 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 blah. Okay, and this is 5.9. Okay, we can add some zeros in here just to make it look nice, but they're the same. Now we work left to right and compare. Aha, we only had to go one extra decimal place to find out that the 5.9 is greater. Now this next one, we're going to line them up vertically. 120%, 1 1/5. We're going to find out what they're equal to. Percent to decimal, 2 places over, because it's divided by 100. That's 2 powers of 10. So it moves a decimal over 2 places. So that's 1.20. And 1 1/5, well, we know the whole number part is going to be 1. But we have to turn this 1/5 into a decimal. 1/5 equals 10. Let's see, how many tenths? Well, times 2, so that's 2 tenths. So, look at that. We got 2 tenths or 20 hundredths, so these two are equal. Are irrational numbers always, sometimes, or never rational? Well, irrational means kind of like not rational, so this is a big never. Number 6, last one, name one set of numbers to which negative 2/3 does not belong. Well, negative 2/3, it's a fraction. So therefore it's rational. So it belongs to rational. What doesn't it belong to? Well, anything that could be turned into like a decimal of some sort. So this would be 0.6 repeating. Anything that's not whole, all right, is not an integer. It's not whole number, and it's not natural number. And also, this number is not an irrational number. So those are all possible answers that you could have. All right, it's not an integer, it's not a whole, it's not a natural number, and it's not irrational either. All right, we are done our quick check. Let's move on. Okay, here we go. So what is equivalence? That is our big question here. It looks like this girl's a little out of balance. Hopefully we can watch that sometime in class, how some of these seesaws got a little out of balance when people went flying off them. What is equivalence? It means that things are equal, and we'll be exploring how to keep things balanced. All right, so if we have some weights over here and some different weights over here, all right, how can we keep these balanced? All right, how can we keep these balanced? What if I were to, take half of that away or cut it in half? All right, what would I have to do to the other side? Would I have to kind of cut that in half? So that's 8. So if I took 4 away, All right, how do we keep things being equivalent, and how do we use equivalence to help us solve problems? All right, next. Okay, you can, if you really want some good, interesting reading, go ahead and read through these. These guide me about what I'm teaching you. Okay, this is all going to be building. This is the simplest part of this chapter, and we're going to build until we have variables on both sides of the equation. We're going to be using fractions and parentheses and all sorts of crazy stuff. But get this foundational information today so you can keep building and not be totally lost when we get to the really complicated stuff later. Okay, today we're going to solve equations using the inverse property of multiplication. We're going to solve equations with rational coefficients. And by rational, they specifically mean actual fractions, mixed numbers, and decimals. What if those coefficients, if your coefficients are decimal? So what they mean is this, 2x equals 14. What's a coefficient? This is a coefficient, all right? The number that's multiplied by the variable. That's what a coefficient is. Coefficient is the number multiplied by the variable. Now, when we want a rational coefficient, this too is rational. So this is not a good way to describe it. They should just say, fractional coefficients or decimal coefficients. But what we're going to be solving today is something like this. All right, where our coefficient, the number that's multiplied by the variable, is an actual fraction. And then we'll also be doing things like this, where you have 0.45x equals 1.25 or something like that. All right, so those are the types of problems we'll be focusing on today. Now, what do we have to learn vocabulary-wise? Please copy these down as we go. Multiplicative inverse, you might know a different word for it, reciprocal. All right, please copy this down. Two numbers with a product of 1. For instance, 2/3 times 3/2 equals 1. All right, like if I had 1/7 times what would equal 1? 1/7 times what? Well, if I multiply by 7/1, then this and this are the exact same thing, and I get 7/7, which equals 1. Yay! So 7/1, or the number 7, is a reciprocal of 1/7. Okay, how about this? 4/5 times what equals 1? What would go in here? Well, if I did 5/4, just flip it, I get 20/20, which equals 1. Yay! So 5/4 is the reciprocal or multiplicative inverse of 4/5. All right, the challenging parts come when we do something like this. Let's say, what's the multiplicative inverse of 1.5? Some of you might real quick think, oh, well, 2 and 2 once. I don't know what 2 once are, but 2 and 2 once. No. Okay, first, you're going to turn that into an improper fraction, right? Which would be 5/2. Then you're going to flip it and get 2/5. So 5/2 times 2/5 equals 1. Why is that? Because you get 10/10, and that equals 1. So numbers that multiply to get you a product of 1, those are called reciprocals, or more sophisticated, multiplicative inverse. All right, we got the coefficient next. We just talked about it, so it shouldn't be a surprise. The numerical factor of a term that contains a variable. All right, so you see how this is a term and this is a term. All right, terms are separated by addition and subtraction signs. And then you have the number, that's what numerical stands for, the number. I can't spell. All right, the number that is next to the variable, okay? The number that multiplies by the variable. So the 2 and the 3 are your coefficients or numerical factors. Okay. Inverse property of multiplication, this just states that if you multiply a number by its reciprocal, you get 1. Multiply a number by its reciprocal, you get 1. So you can see here, if you just flip it and multiply, you get 1. Okay, we're going to be using that property to isolate variables, to get rid of stuff, to turn it to 1 so we don't have to deal with it anymore. All right, because that's what we want to do today, solve equations. Here's our first equation. All right, you're going to have to slow it down because I'm going to go through it pretty quickly. All right, we have 3/4 C equals 18. What could C be? How can we figure it out? I like to say this. All right, use inverse operations to isolate or get by itself the variable. All right, we're isolating that variable. We're getting it by itself. So how can we do that? Well, we're going to write it neatly in your notebook, lined up inside those lines beautifully. Okay, it's very important to keep everything neat and organized so you don't make those silly mistakes that are so frustrating. Here we go. So, whoa. What just happened here? Let's go back. All right, well, first step always is to find the variable. Hello, C. Now, the next step is to see which operation is happening here. So, looks like multiplication, right? When a number is next to a variable, it's being multiplied. So, we have multiplication in there. Well, we could, I guess, to do the inverse operation, we could divide by 3/4. That would work. Divide by 3/4. But it's going to be simpler. Remember, dividing by a fraction is the same as multiplying by its reciprocal. You learned that last year. Dividing by a fraction is the same as multiplying by the reciprocal. So instead of going like this, divide by 3/4, divide by 3/4, we're just going to skip the division step and go straight to multiplying by the reciprocal. Okay, multiply this side by the reciprocal. Okay, why did I do it to both sides? It's because it's like a balance, right? If you do something to one side, you have to do it to the other. All right, let's move on now. We can multiply by the reciprocal to isolate the variable. We can cancel out the 3/4 by multiplying by 4/3. All right, so we're just cleaning things up. What happened in here? We just wrote 18 as a fraction by putting it over 1. And now we're going to cross simplify. Whoa. What just happened there? Okay. We're going to start multiplying, right? We're going to multiply the fractions. But before we multiply, to make it easier, we're going to cross simplify. That just means cancel out any common factors in the numerators and denominators of the fractions. All right. So for instance, I see 3 and 18. Does anything go into both of those evenly? 3 does, right? 3 goes into 3 once, and 3 goes into 18 6 times. All right? So you can see they just do it real quick. Boom. All right, now you have everything simplified. So it would kind of be like this. 1 over 1 times 1 over 1 C equals 4 over 1 times 6 over 1. All right, so it just simplified everything down, everything that's left over. It's kind of hard to see sometimes, but let's see what we get when we simplify that. All right, the 1 times 1 gets us 1. The 1 times 1 on the bottom gets us 1, which this then equals 1, and then 1C. Well, 1 times anything is just that number, so we don't have to write the 1. All right, on the other side, we get 4 times 6, which is 24. 1 times 1, which is 1, and that simplifies down to 24. Okay, now comes the check. This is the part that nobody likes to do, but it helps make sure that you're on the right track and that you're doing things correctly. Right? So what is a check? A check, you're going to label it. then you're going to write the original equation down. We're going to write the original equation. All right. And now in red, you see the C in red inside the equation. We know, or at least we think we do, we think we know that C is equal to 24. And if I ever know that two things are equal, I can substitute one in for the other. So what did we do here? We just replaced C with 24. And now we're just going to test out to see if this actually does equal this. See if it's balanced. See if when we plug in what we think C equals, see if it actually balances it out. Were we correct? Did we follow the procedure the right way? All right, well, how would you multiply 3/4 times 24? You have to pop a 1 under there and then cross simplify and cancel, just like you would normally with when you're multiplying fractions. Okay, so there we go. There's supposed to be a multiplication symbol in there. Right, cross simplify, and it does in fact equal the other side. So when we substituted our answer in, it actually worked. It did balance this out. Boom. So 18 equals 18. That is the secret number that would make this seesaw balance. Yay. All right. We got to move to the next one. Let's go. Okay, here's your chance to try it. Try it. Check your answer with me. Okay, pause. Try it. Write the equation. Find the variable. Now, isolate that variable by using some operation that will cancel that out. Either, now we know that you can either do an inverse operation, or if the coefficient of fraction, we can actually use the same operation, right? Because multiplication. And then, but what type of multiplication can cancel that 2/3 out? Multiplying by the reciprocal. And multiply the other side by the reciprocal because by that same number, 3/2, because we have to keep it balanced. All right, now that cancels out to 1. 1a, right? 1a, but I don't actually have to write the 1. But it's good to know that you do get a 1 there. All right, now how do I multiply these? The 12 times the 3/2. Got to put a 1 under there. I cancel. I cross simplify, actually. I cross simplify. And I get a common factor of 2. 2 goes into 2 once. 2 goes into 12 6 times. So I'm going to multiply my numerators. 6 times 3 is 18. Multiply by the denominators. 1 times 1 is 1. And now I can simplify. 18 over 1 is 18. All right, my check. Do the check over here. Okay, I rewrite the original problem. 2/3 a equals 12. I substitute in for the variable the number that I think it equals, which is right here in my answer, which is 18. Now, I'm not solving anymore. I'm just simplifying to see if, in fact, the left side does balance out with the right side of this equation. Put it over 1, you get 1, and that gets me 6. This equals 12. This equals 1. So it looks like it does balance. Check. All right, so this is just wondering, is it equal? Is it going to be equal? Yes, it is equal. Okay, it's just testing it out. It's not solving. You're not doing inverse operations during your check. You're just testing out what you got. Yay, we did it. Now, some of you might be like, but Mr. Woodard, you got 12 equals 12. It's not 18, right? Down here in my check. No, that was just making sure that 18 was the right answer. This is my answer right here. There it is. All right. Ooh, oh boy. Look at that. Look at that. Ouch. Looks scary to me. All right, but I think some of you could possibly figure this out, even without me. All right, what are we going to do here? What do you think? I think that we're going to need to go with, what just happened? Is that a new equation? So the same equation written in a new way. Right? What did they do? They just changed those mixed numbers into improper fractions. So we're going to rename, right? Change mixed numbers into improper fractions. Okay, that's all we had to do. And now it's the same as the ones that we had already solved. All right, so how are we going to do that? How are we going to get rid of this 3/2 that is the fractional coefficient? We could divide by 3/2. Or I can multiply by the reciprocal. All right, multiply each side by the multiplicative inverse of that coefficient 3/2. All right, now we're going to get ready to cross simplify, make sure we make our lives easier by simplifying before we multiply. Boom. Wow. Lots of cross simplifying. I like those problems because it makes the numbers really easy to multiply at the end. Of course, the s is going to be by itself, and the right side of the equation comes to 11. Okay, so the only new step is right here when we have to rename and change mixed numbers into improper fractions. All right, so it's fairly simple. All right, fairly simple so far. Let's try it. Pause, try it yourself, then check your answer. 2 1/4 b equals 18. We're going to rewrite this and this as improper fractions. So times plus gives me 9/4. B equals 18 over 1. Now that we have all just regular fractions, no mixed numbers, we can isolate this variable by multiplying by the reciprocal. So we have times 4/9, and we have to do the same thing to the other side, same exact thing, 4/9. Okay, that cancels to 1. The number times its reciprocal always equals 1, so we get 1b, but we don't have to write the 1. And then we can cross simplify. 9 goes into 9 once, 9 goes into 18 twice, and we have the numerators, 2 times 4 is 8. The denominators, 1 times 1 is 1. So we get b equals 8. There we have it. 8 is great. Now we could substitute that in and check, but I'm not going to bother with that right now just for sake of time. All right. So our last example for the day, is this problem. Now we could change it to a fraction and then do what we just did, but we're just going to keep it simple here. We're just going to use the inverse operation in this case. All right, actually I don't even have to write it. We're just going to use the inverse operation. So you can notice the n is right here. What operation when number is next to a variable? A multiplication. So what's the inverse operation that we can use to isolate the variable? That would be division. So we write the equation. Then we divide by the coefficient. And you can use a calculator, guys. Right? Just calculate this. How would I type that in? I'd say 3.15 divided by 0.45 in your calculator. It'll pump out the answer, and that answer is 7. 7 equals n. I like to slash those out when I cancel them out. It makes me feel good. It makes like I'm really isolating that variable. Getting rid of everything using inverse operations. All right, then we can check it. We rewrite the original. We replace that variable with the number we think it equals, and we test it out, and looks like we balanced it. So then we can circle this with confidence because we checked our answer. All right. That was our last example. This is our last test for you. Okay, try this, and then unpause and check. All right, we go to the variable. We figure out what operation is going on. We do the inverse operation, so it's multiplication, so we divide by 0.9. We do that same thing to the other side to keep it balanced. And we get a whopping, let's see, that would be, I think 12. But I'll do it on my calculator just to be sure. Oh, nope, I'll just check with that. There you go. It is 12. Boom. Hopefully you got that. Again, you can check by just substituting in the 12 there, multiplying it by 0.9, and seeing if it actually does equal 10.8. Okay, we'll come back to the last little part of this lesson later. That is all for now. Bye-bye.